So picking up where we left off here, okay, so I did all the math for the Pythagorean theorem on this side here in the calculator. Okay, hit enter. I want to divide it by, make sure you get a parenthesis in there, 2 times 2.57 times 4, and I get here. Okay, so basically I have so what you gotta do from there is we just inverse this. Okay, 48.5. Now, nice thing is, once we have beta, you can go up here, you can plug that guy in. And once you get two angles, third angle is actually really, really easy. So we're just going to take 180, take the answer away, take the 40 away, and 91.4. Okay, you take a minute to see if everything kind of matches up here. So angle A looked like the smallest, 2.57, that looks good. Angle B is the middle angle, the side's a 3, that looks good. Angle C is the biggest side, so that should be the biggest angle. And that guy also looks good. Now when you look at solutions here in the book, they're probably going to be all typed up like this. So they basically just took our formula here, they swung the 2AC cosine beta over like we talked about, and they showed all the division here. You don't have to show me all this, but if it helps you stay all organized, I'd encourage you to do it. Just make sure it's all punched in the calculator correctly. But you know, you should get all the setup in, and then you should have cosine whatever equals the decimal, and then go from there. Okay. There's a side angle side case with those. So the last one to look at here is the side case. Okay, we can have side because sides set angles. There's no angle, if you'll remember from geometry, because those triangles can really just be scaled all over the place. So I could have a triangle here with those set angles. I could take this guy here. It's got the exact same angles, different sides, and clearly those aren't congruent. Okay, so there's no angle with it. So if we have these three right here, okay, you get to pick which law of cosines you'd like to use. So there's our three formulas for us again. It's really up to you which angle you want to find first. You're going to have to find all three anyway here, so we might as well just pick this first one. Okay, so here's the C, here's the A, here's the B if it helps you to label those guys like that. So it wouldn't hurt if you guys went along and check these in your calculator, make sure you're getting the same numbers I am. Can't encourage you enough to get everything all set up here. Okay, so this guy's going to be another one we got to go ahead and solve for C here. So again, I'm going to take all this junk here, swing it to the other side. I'm going to take the 49 and swing it to this side as well. Make sure this guy gets divided by these all in a parenthesis here. So we've seen -1/2 before. We should know where that happens. We can draw triangles, but since we're using our calculators anyway, 120. Okay, so that'll tell us the degree where this guy happens. So what you just found Now again, we could go do a law of sines now because we have enough information. But like I said, if you start law of cosines, you should stay law of cosines so you don't screw yourself up. We're just going to have to do another law of cosines now to find another angle. So it won't matter which one we do. Let's pick this guy here. So once you get this guy all set up, make sure everything makes sense here in that you have a 3 and a 7 with a 3 and a 7 here. Whatever side you have over here, the 5, you better have cosine of beta over in this guy here. Okay, now all we got to do is solve this guy, and I'm just going to go straight to the calculator here because we've done enough of them now. Okay, and then divide this by the 2 times the 3 times the 7, and there's your decimal. So we take that guy there, inverse it, spits out 38.2 at me. Now for the last one, you could go do this law of cosine if you want to make sure that your alpha will fit, or once we have two angles, it's pretty easy to find the third angle just from triangle sum theorem. But if you want to make sure your answer is correct, you could do a third law of cosine. $21.7. Okay, everything looks good there with the book. Again, they're showing you how they kind of set all these guys up. Pay attention to math, make sure it's done correctly, obviously. Here's the last thing and the reason why once you start with something, you need to stay with it. So when we do inverse sines, they can happen quadrant 1 or quadrant 4 and be positive. So for example, if this is 30 degrees down here, that gets you the exact same value over here at 150. So that's where we got to check for the double triangle. So we inverse a sine, it can happen quadrant 1 or its equivalent over in quadrant 2. Now if there's enough room with this new angle and the given angle, you can make a second triangle. The law of cosines is nice because the places cosine are positive, 1 and 4, to get to quadrant 4, you got to go more than 270. If you go more than 270, you're automatically over a triangle, so that won't work at all. Okay, so law of cosines is nice, even though the math's a little bit tougher, but you never have to worry about this case here. Okay, so once you start law of cosines, if you shift to a sine, how do you know whether it's the quadrant 1 or the quadrant 2 angle? Okay, and the best thing I can tell you is once you start, just stay with it.